Well, hello again. Today we're going to start Chapter 3. This is the first lesson in Chapter 3 on arithmetic sequences. So first let's define what an arithmetic sequence actually is. It's a list of numbers that increase or decrease by a constant amount. So they can either go up by the same amount or they can go down by the same amount. That amount of increase or decrease is referred to as the common difference. So get used to that terminology. And also, if you have three terms in a row, A, B, and C, then B, which is in the middle of A and C, it's actually called the arithmetic mean of A and C. All right, so here's some examples. We have 2, 5, 8, and 11. That is an arithmetic sequence. It starts at 2, and it has a common difference of 3. Then we have 5, 3.5, 2, 0.5, and negative 1. That one starts at 5, and it has a common difference of negative 1.5. All right. So for notation purposes, we need to get used to how these things are written. So the terms are written using the letter U. So U1 is the first term, U2 is the second term, U3 is the third term, and so on. Okay, and the common difference is referred to as D. So if I wanted the nth term, or UN, it can be written in one of two ways. You can write it recursively by referring to the term that came before. So the nth term will be the n minus 1th term, the one just before it, plus D. Or you can write it explicitly by saying that UN is equal to U1, the first term, plus D being added n minus 1 times. So that's kind of how it makes sense to think about it. To get from the first term to the nth term, D has to be added n minus 1 times. All right, so here's an example, and we're going to go over some questions that you might be asked about arithmetic sequences. So first of all, you might be asked, is the sequence arithmetic? And to do that, we subtract each pair of consecutive terms that I have. And I need at least 3 terms in the sequence to know that it's arithmetic. Otherwise, I have no idea. So if I subtract the second term, 11, minus the first term, 5, I get 6. And if I subtract 17, which is the third term, from the second term, which is 11, I will also get 6. And if I subtract the fourth term, 23, minus the third term, 17, I also get 6. So it is arithmetic because all of these differences are the same. If even one of them was off, then the sequence would not be arithmetic. All right, so the second question I could ask is find a formula for the general term UN. And to do that, I need to know 2 things. I need to know what the first term is, and I'll call that U1, and I need to know what the common difference is, and I call that D. So I'm going to find those values. We already know that D is 6 because I already checked that. And I can just look and see that the first term is 5. So U1 is going to equal 5. So I use my formula that I told you about before. UN equals U1 plus n minus 1 D. N is going to stay a variable because I'm looking for the general nth term. So I'll replace U1 with a 5 and I'll replace D with a 6. And that's what it looks like. And if I expand the parentheses and simplify it, I get that UN equals 6n minus 1. All right, so that's how I will get the nth term, is just to plug in what term I want into that formula, and it will tell me what the term is. Okay, now suppose I wanted to find the 1000th term. Well, I could carry the sequence on to 1000 terms, but that would be too time consuming. So I'm going to use the formula, which is what I found before. UN equals 6n minus 1. And since I want the 1000th term, that's U1000, and that will be calculated as 6 times 1000 minus 1. That ends up being 5,999. So that would be the 1000th term in that sequence. All right. Moving on, the next question I could ask is, does the number 459 appear anywhere in this sequence? Well, I know it starts at 5 and I know it goes up by 6s, so I could keep doing that until I either do or don't run across 459. But there's another way to do it more algebraically. Remember, the formula for the nth term is 6n minus 1. So is there a value of n so that 6n minus 1 equals 459? Well, if I solve that, I get that 6n equals 460 and n equals 76.66666. And so since n is a term number, I don't have a 76.6666 term. So it looks like that number 459 does not appear in the sequence. All right. Another question I could ask: does the number 551 appear in this sequence? So I wanted to give you an example of one that didn't and one that did. This one does. So again, I let the general term 6n minus 1 equal 551. And I solve. So 6n would equal 552. And so n would equal 92. N is a term number, and a term number is allowed to equal 92. So the 92nd term is going to be 551. All right, so 551 does appear in this sequence as the 92nd term. The next thing I want to talk about is how actually does this relate to linear equations. Well, you saw the general term was un equals 6n minus 1. And whether I'm using u's and n's or x's and y's, this is a linear relationship because the exponent of n in the expression on the right is 1. And anytime the highest exponent in an expression is 1, then you have a linear relationship. So that would be the same thing as y equals 6x minus 1. And if I graphed the term number and the actual term on a graph, those dots would join up to make a line. So that's kind of how it relates to linear equations. I just kind of wanted to link that. That's it. So if you have any questions, let me know, and I will see you tomorrow.